Have you ever stopped to wonder how you can stream a movie, jump on a video call, and have like a dozen tabs open all at the same time without the entire internet just grinding to a halt? Well, the answer lies with this unsung hero, a sort of digital traffic cop that's been quietly managing the chaos for decades. So let's dive in and demystify the master of control behind it all, traditional TCP.
I mean, seriously, think about that for a second. We've got billions of devices sending trillions of data packets every single day. It's a recipe for total, absolute collapse. So what's the secret sauce? What's this invisible force that's preventing a digital apocalypse? Well, the answer is the very protocol we're here to talk about.
So here's what we're going to cover in this explainer. First, we'll get into what traditional TCP actually is and what it does. Then, we'll see how it fights the constant battle against network congestion using its own special toolkit. And finally, and this is the big one, we'll uncover its one critical weakness when it comes to our mobile world.
All right, section 1. So, what exactly is this thing, this digital traffic cop that pretty much the entire modern internet is built on?
Okay, so TCP stands for Transmission Control Protocol. It's a key part of what's known as the TCP/IP suite. You can just think of that as the official rulebook for the internet. And its main promise? It's right there. It guarantees that the data you send actually gets where it's going, reliably, and, this is crucial, in the right order. No missing pieces, no jumbled up messages.
So, TCP's job really breaks down into 3 main parts. First, like we said, reliability. It makes sure no data gets lost. Second, it plays that traffic cop role, controlling congestion so the whole network doesn't get jammed up. And third, it manages the flow, making sure a sender isn't blasting data faster than the receiver can actually handle it. You can see it's a really delicate balancing act.
Okay, now let's zoom in on that second job. Because honestly, it's the most critical one for keeping the internet from falling apart. This constant, unseen battle against congestion.
And this is really what's at stake. Without TCP actively managing things, the internet would suffer from something called congestion collapse. Trust me, it's as bad as it sounds. It's a catastrophic event where the network gets so clogged with data that performance just plummets, and basically nothing gets through. TCP is the shield that protects us from.
And this is a great way to think about what congestion actually is. It's not a broken cable or some software bug. It's just a traffic jam. Imagine way too many cars trying to merge onto a highway at once. That on-ramp gets totally backed up, and some cars just can't get on. In the digital world, those cars are our data packets.
And this whole problem has deep roots, right? TCP was originally designed for wired networks, where congestion happens for a very specific reason. In that world, when a router's memory, what's called its packet buffer, fills up because data is coming in too fast, it has no choice. It has to start dropping packets. It's kind of like our highway on-ramp deciding to just vaporize the cars it can't handle.
Okay, so TCP knows congestion is the enemy, but how does it actually fight back? Let's open up its toolkit and see how it manages these digital traffic jams.
This right here is the single most important assumption TCP makes. See, when a sender sends a packet, it waits for a little confirmation message to come back from the receiver. That's called an acknowledgement, or ACK for short. If that ACK doesn't show up, TCP makes one single critical assumption. Aha! There must be a traffic jam.
So, in response to that assumed traffic jam, TCP kicks off a safety protocol called slow start. Look at step 1. It gets real cautious, sending just one single packet. Then, after one round-trip time, that's the time it takes for the confirmation to get back, it doubles its sending rate to 2 packets. Then it does it again, doubling to 4. This exponential growth you see here is how TCP carefully feels out the network's limits without making things worse. But, slow start can be, slow. So TCP has some smarter tools in its kit. If a sender gets a bunch of ACKs for the same piece of data, that's a clue that maybe just one single packet got lost and the whole network isn't melting down. So Fast Retransmit intelligently sends just that missing piece right away. Then, Fast Recovery builds on that and lets the sender skip that whole cautious slow start process. This gets the connection back up to full speed much, much faster.
For decades, this whole system worked beautifully. It was elegant. But then, the world changed. We all went mobile, and suddenly, TCP's single most important assumption was just plain wrong.
And here is the fundamental problem. In the wireless world we all live in now, that core assumption that a lost packet always means there's a traffic jam is just not true anymore.
I mean, just look at the reasons why. A packet might get lost because of a little bit of interference, a simple transmission error,
Or maybe you just walked from your living room to your kitchen and your phone switched Wi-Fi access points. But TCP, it can't tell the difference. It just sees a missing ACK, screams congestion, and slams on the brakes by going into slow start, needlessly crippling your connection speed.
And we're not talking about a minor inconvenience here. The performance hit is, and this is a direct quote, severe. It's this great paradox. The very design that made TCP brilliant for a wired world becomes its biggest flaw in a wireless one.
So you might be thinking, why not just fix it, update the assumption? Well, here's the catch. We can't. TCP is so deeply baked into every router, every server, every computer on the wired internet that changing it would be like trying to replace the foundation of a skyscraper while people are still working on the 80th floor. It's just not going to happen.
And that leaves us with this really fascinating puzzle. We have a protocol that's absolutely essential, but it's fundamentally flawed for the mobile world we live in. We can't change it, yet it has to work. So the real question becomes, how does the internet adapt? And that challenge is precisely what led to a whole new generation of clever solutions and workarounds.